There are things the universe should never reveal, laws it never meant to break. But James Webb just saw something that shouldn't be there. In the vastness of space, there are rules ancient and unforgiving. The universe, for all its chaos, obeys a structure. Like a composer following invisible sheet music written in particles and light. For decades, cosmologists believed they understood the melody. And then, something played out of tune. When the James Webb Space Telescope opened its golden eye to the earliest epochs of existence, it wasn't just gazing backward in time. It was walking into the mythic childhood of the cosmos, a time before galaxies should have formed, before stars should have bloomed. But what it found was not infancy. It was complexity, maturity, and contradiction. Galaxies brilliant, ancient, fully formed stood calmly in the deep past, as if they had always been there. Some less than 300 million years after the Big Bang. A blink after creation. According to our models, that's too early, too developed, too impossible. Imagine walking into a nursery and finding philosophers. That's what this is. Not merely a surprise but a violation. The galaxies James Webb discovered weren't hazy clouds of infant stars. They were massive, organized systems. Some rotated with purpose. Others contained chemical signatures of elements that should have taken billions of years to form. And then there's the light. Light that shouldn't have made it here at all, not in such quantity, not with such brightness. Objects shining with the luminosity of 100 billion suns, at a time when stars were supposed to be flickering into being for the very first time. The tension in the scientific community wasn't immediate panic. It was a quiet unease. Emails with subject lines like unexpected results, papers hastily revised, simulations that broke under the weight of new data. Because this isn't just a discovery, it's a contradiction, one that slices through the heart of our understanding. The standard model of cosmology, the lambda cold dark matter model, doesn't easily make room for these findings. We expected to see small, chaotic proto-galaxies assembling slowly. What we saw instead were giants. Ancient cities of stars, already thriving, already rotating in strange synchrony. And it wasn't just one, it was dozens, then hundreds, and soon, perhaps, thousands. The universe, it seems, has secrets older than our physics. We were supposed to confirm the timeline. Instead, we may have uncovered evidence that it's wrong or incomplete, and the implications are profound. If the early universe was already organized, already mature, then what gave it that head start? What force, what structure, what inheritance allowed complexity to leap forward when there should have been only chaos and light? Could the blueprint of these galaxies have come from somewhere else? Could the very beginning of our universe be the continuation of something older, deeper, more deliberate? We don't yet know, but what we do know is this: the cosmos we thought we understood has changed forever. And in the next chapter, we'll follow this thread deeper into the very origins of cosmic structure and the theories now under siege because of what Webb saw. The nursery was never empty. Something or someone was already there. There are instruments we build not to question, but to confirm, to polish the truths we think we already hold. The James Webb Space Telescope was one of them. It was meant to be the great validator, the final eye that would see far enough into the past to cement our understanding of the universe's birth and growth. Not to challenge the Big Bang theory, but to illuminate it more clearly. To witness galaxies forming, stars coalescing, matter organizing from the primordial fog, all in perfect alignment with what we expected. But the universe had other plans. When Webb unfolded its massive golden mirrors and gazed into the deep abyss of cosmic time, it wasn't just unlocking old light, it was unsealing old secrets. And those secrets were wrong. Instead of faint, shapeless blobs of gas barely beginning to form, Webb saw fully structured galaxies. Massive, complex, spiral arms already coiled, cores burning bright, systems that, by every timeline we believed in, shouldn't have existed yet. These galaxies weren't supposed to appear until hundreds of millions or even billions of years after the Big Bang. But there they were, shining back at us from just 200 million years after creation. It's like finding skyscrapers buried in the ruins of the Stone Age. Too early, too advanced, too complete. And that changes everything. Because if the skyscrapers are already there, you're forced to question not just the timeline but the entire blueprint of the cosmos. Webb was designed to see farther and older than any telescope before it, peering into a time when the universe was still young, still fragile, still assembling itself. We expected a gallery of galactic infants, wisps of cosmic dust slowly clustering into stars, disorganized clouds of hydrogen struggling to ignite. What we got were ancient giants, cities in the sky already built. The implications ripple through the fabric of cosmology. For decades, our standard model of the universe's evolution, a slow, methodical climb from simplicity to complexity, has guided everything from simulations to schoolbooks. But the data from Webb strikes at the very foundation of that model. Because these galaxies didn't just appear early, they appeared mature. They contain metals and elements that should have taken countless generations of stars to forge and disperse. Their shapes suggest internal order, their brightness, immense mass, and the rate of formation far too rapid. In cosmic terms, it's like watching a child become an adult within hours hours of birth, skipping all the messy stages of growth. That kind of speed implies that something is wrong, not with the galaxies, but with us, with our assumptions, with the scaffolding of cosmology itself. We were prepared to confirm. Instead, we were contradicted, and scientists felt it not with cinematic drama, but with a deeper, more unsettling kind of fear. What if we've misunderstood everything about how the universe grew? One discovery like this could be dismissed, but Webb found many, too many to ignore, each one a quiet rebellion against our cosmic expectations. Suddenly, the narrative we've told ourselves that galaxies slowly assembled from small structures, gradually merging into the colossal systems we see today, began to unravel. How could such fully formed galaxies exist when the universe had barely begun to cool? Did the early universe evolve faster than we thought? Was there something in those primordial seconds, a mechanism, a pressure, a force that seeded advanced structure right from the start? Was dark matter more influential than we imagined? Or did inflation, that brief moment when space itself expanded faster than light, leave behind strange consequences we still don't understand? Or are we missing something fundamental about time itself, or about how matter behaves on the grandest scales? These are not fringe questions. They are now central, because James Webb didn't just photograph galaxies. It photographed a cosmic contradiction, and in that contradiction lies the possibility, terrifying and thrilling, that we don't know the rules anymore. It's a moment of epistemological vertigo, when the ground beneath science itself feels suddenly soft. When we set out to confirm our vision of the cosmos, we didn't expect to be met with silence, and then disobedience. The early universe was supposed to echo our theories. Instead, it whispered something unfamiliar, a new story, or perhaps, a much older one. And this is just the beginning. We thought time was the sculptor of the cosmos, but what if time was cheated? We've always believed the universe told its story through the slow patience of time, from the quiet ignition of the first stars, to the long dance of galaxies growing from collisions and mergers. Time was the chisel, space was the stone, but now something doesn't add up. In July 2022, the James Webb Space Telescope focused its vast golden eye toward a region of deep space and captured light from a galaxy named GN-Z11. It is one of the most distant and therefore earliest galaxies we've ever seen, but what it revealed wasn't youth. It was age, complexity, weight. The galaxy's light had been traveling toward us for over 13.4 billion years, placing it just a few hundred million years after the Big Bang. And yet, GN-Z11 appears massive, organized, and rich in heavier elements, metals that should only have formed after multiple generations of stars lived and died. And it wasn't alone. In another deep field, the CRS, Cosmic Evolution Early Release Science Survey, Webb found a series of similar anomalies, galaxies like CRS 1749, SURS 93316, and GLASS Z13, each one seeming to defy the cosmic clock, each one far too mature for its age. These galaxies shouldn't just be unlikely, they should be impossible. To form stars, gather dust, undergo chemical evolution, and settle into a structured shape all within 200 million years of the universe's birth demands processes that are orders of magnitude faster than any of our existing models allow. It's not a minor miscalculation. It's like opening a history book to page 1 and finding entire civilizations already standing, cities built, languages spoken, empires risen, before the supposed dawn of humanity. And scientists felt it. Dr. Erica Nelson, an astrophysicist at the University of Colorado, said of these findings, "There are galaxies that are just too big, too early. It challenges our entire framework." Astronomers began scrambling to adjust models. Maybe these galaxies formed from extraordinarily dense regions of gas gravitationally collapsing with unheard of efficiency. Maybe dark matter played a more aggressive role in the early universe. Or perhaps the rate of star formation was just wildly faster than we thought. But every explanation felt like a bandage stretched across a wound too deep to ignore. One astrophysicist, speaking anonymously, remarked, "This isn't just about mass. It's about time. Something doesn't fit and we don't know what." Because time, in cosmology, is not just background. It's not just a passive dimension. It's the canvas on which all structure is painted. If time has been misread, then the entire portrait may be wrong. And that's the unsettling possibility. That time itself, as we measure it across cosmic distances, might not be behaving as we thought. Could the early universe have expanded and cooled differently than we assumed? Could light, bent and stretched by the deep fabric of space, be giving us the illusion of age where there was none? Or more radically, could our interpretation of redshift, the measure of how light stretches across space and time, be incomplete? We rely on redshift to tell us how far away and how old distant galaxies are. But if there are unknown distortions in spacetime, if gravity has subtle effects on light we haven't fully accounted for, then some of what we see may not be what actually is. These are not comfortable questions for science. And yet they must be asked, because if these galaxies truly are as old and massive as they appear, we are looking at the collapse of a timeline we've spent a century building. A quiet revolution may be underway, one not announced with fireworks, but with silence. silence. With light that should have taken billions of years to organize into stars and spiral arms, already doing so in the universe's first blink. If time has been cheated, then by what? By what force could the universe rush forward so quickly, skipping steps, breaking laws? We don't have the answer yet, but this is the essence of science. To sit with the discomfort of the unknown, to accept, even fearfully, that what we believe may be incomplete or wrong. And beneath all of this, the data, the recalculations, the theory revisions, is something deeper, something philosophical. Because if time is not the slow, impartial architect we imagine, if time can be bent, rushed, or disguised, then what else in our universe is not as it seems? Could our own place in the cosmos, our sense of when and how we arrived, also be under question? Are we a recent flicker in a long-forgotten history, or are we staring into a mirror, unable to recognize the reflection of a universe that formed not slowly but in sudden, overwhelming bursts of structure and energy? And if galaxies were born that fast, what of light? What of consciousness? What if the same rush that built stars also accelerated the emergence of minds? These questions may seem vast, even unreachable, but so was the light from GNZ11. Until we built the tools to catch it, the universe has always spoken in whispers. James Webb is helping us finally hear them, and what we're hearing now is the sound of the cosmic clock breaking. Every image Webb returns is a challenge not just to our knowledge, but to our place in the universe. There are places in the cosmos where light bends, not gently, not softly, but violently, as if space itself is buckling under a hidden weight. The James Webb Space Telescope wasn't just built to look far, it was built to look deep, to see into the earliest folds of time. But what it found there was not silence, not order, but shadow. In one of its first full-resolution deep-field surveys, an image that took only a day for Webb to collect but would have taken weeks for Hubble, something strange became clear. There were patterns where there should have been chaos, alignments where there should have been randomness, and clusters far too large, far too soon. Among the most troubling features were gravitational lenses, vast arcs of distorted light bent not by glass but by invisible mass. These arcs, like fingerprints on the window of the cosmos, tell us that something immense is hiding in the dark, warping the path of ancient photons. In some frames, entire galaxies appear duplicated, stretched into echoes of themselves. In others, light seems to twist unnaturally, as though space has been torn and folded. Now, gravitational lensing itself is well understood. It's a confirmed consequence of Einstein's theory of general relativity. But what Webb is revealing are anomalous lenses, distortions with no obvious culprit. No massive galaxy, no black hole, just space behaving in ways we can't explain. Some of these distortions hint at the presence of so-called dark galaxies, massive structures composed almost entirely of dark matter, invisible to our telescopes, yet strong enough to bend the light of everything behind them. Others suggest a far deeper violation, that the universe may be structured in ways that contradict cosmic inflation, the very mechanism we believe caused the Big Bang to spread outward at faster than light speeds, ironing the universe into smoothness. But what we see is not smooth. In Webb's images, we find clusters of galaxies so large, so gravitationally coherent, that there hasn't been enough time since the Big Bang for gravity to have pulled them together. This isn't a trivial miscalculation. It's a violation of the universe's growth speed limit. If cosmic inflation smoothed out the early universe, why do we now find giant structures, filaments of matter, and superclusters billions of light-years across existing long before they should have had time to form? It's like stepping into a forest where saplings should be, and finding towering redwoods instead. And then, there are the quasars, monstrous beacons of light, powered by supermassive black holes devouring matter at unimaginable speeds. Webb has detected some of these luminous engines, just 400 million years after the Big Bang, far earlier than any current model allows. To form a black hole that massive, and to feed it enough material to shine as brightly as it does, should have required at least 1 billion years. And yet, there they are, already burning. Each of these discoveries brings the same quiet fear to those who study them, because they are not errors in the data. They are data. The universe is not broken. Our understanding is. And the more we look, the stranger it gets. Some researchers have reported unusual redshifts in certain galaxies, light stretched farther than it should be, even when accounting for distance and expansion. In a few cases, galaxies appear to be moving in ways that defy the expected flow of cosmic expansion, perhaps caught in immense gravitational currents, or perhaps hinting at unknown forces at play. There's a creeping awareness, even among the most grounded cosmologists, that something fundamental is missing. Not just a variable, not just a tweak, but a foundation. And beneath the science, beneath the math and models, there's something deeper, a growing unease. Because these aren't just abstract puzzles, they're cracks in the glass through which we've been watching the cosmos. And if that glass shatters, we may find that we've been staring not at the universe as it is, but as we wanted it to be. This is the quiet terror of discovery, to look into the deepest voids and find them crowded, to expect silence and hear noise, to seek order and find designs we can't explain. Some scientists scientists whisper of modified gravity, of higher dimensions, of early universe physics that operated under rules we no longer see. Others consider that dark matter and dark energy, which together make up 95% of the universe, may not just be invisible, but misunderstood. If dark matter can form structures early ahead of normal matter, perhaps it seeded the galaxies we now find too soon. Or perhaps the early universe was denser, more turbulent, more chaotic than we've ever imagined, and what we thought was a gentle unfolding was, instead, a storm. But here is the deeper truth. Every answer leads to more questions, and every image Webb sends back is a mirror not just of space, but of ourselves, of our assumptions, of our limits, of our longing to know where we truly are. Because when we gaze into the deep field, we're not just looking into the past, we're looking into the architecture of reality itself, and something in that structure doesn't want to fit. These shadows, these strange alignments, these impossible quasars, these gravitational ghosts, they whisper that the universe may not be what we think, and they ask, without mercy, are we ready to know what it truly is? In the next chapter, we'll confront that question head-on, diving into the implications for the Big Bang itself. Because if the early universe is this strange, then maybe, just maybe, it didn't begin the way we've always believed. When the universe breaks your rules, what do? Rewrite the laws or admit you never understood them? Science is often thought of as a fortress, a structure built on the foundations of certainty, evidence, and logic. But even fortresses can crack, and sometimes they tremble. When the James Webb Space Telescope began transmitting its earliest findings, the reaction in scientific circles wasn't celebration. It was hesitation, not because the data was wrong, but because it wasn't supposed to be possible. Galaxies, massive, luminous, structured, appearing when the cosmos was still an infant. Supermassive black holes already devouring matter. Quasars burning as though they'd had eternity to grow, not mere hundreds of millions of years. It didn't add up. And for a discipline that has long prided itself on predictive power, the failure wasn't just academic. It was existential. In astronomy conferences and research forums, debates quickly turned inward. Some researchers argued that the problem lay not in the universe, but in our models of galaxy formation. Perhaps stars ignited earlier than we thought, perhaps matter clumped faster, or cooled more efficiently in the early dark. This line of thinking led to a flurry of recalculations. New computer simulations tried to cram more material into smaller timescales. More gas, more heat, more feedback loops. If the universe was more chaotic, more violent, maybe, just maybe, it could have assembled these ancient structures on time. But as the data continued to flow, those models bent under pressure. Because the galaxies weren't just early, they were mature, too smooth, too metal-rich, as though they'd had eons of evolution, not a few 100 million years. Other scientists began to look deeper, not at the galaxies themselves, but at the framework behind them. Perhaps dark matter behaves differently than we believe. Maybe it interacts not just gravitationally, but thermodynamically, seeding galaxies faster than expected. Or maybe there's a new force, a hidden field, a tweak to the cosmic recipe that allowed gravity to act faster in the primordial soup. These were radical ideas, but not reckless. Theoretical physicists have long considered alternatives to standard models, modifications of gravity, scalar fields, even interactions between dark matter and dark energy. Now, Webb's data was forcing those whispers into the open. Still, in the quiet corners of research departments, some went even further. They asked the unthinkable. What if the Big Bang model itself is incomplete? Not wrong, but missing something. Perhaps the universe didn't expand from a singularity. Perhaps the cosmic inflation phase, that miraculous, faster-than-light ballooning of space, didn't happen the way we imagine. Maybe time, or spacetime, or causality itself is more complex than our current equations allow. For decades, the lambda-CDM model, our standard cosmological model, has served us well. It explains the microwave background radiation. It predicts the abundance of light elements. It accounts for the large-scale structure of the universe. But now, it's showing strain. And when you press scientists on what it all means, they don't reach for press releases. They pause. In interviews, in quiet moments away from the cameras, you hear it. I don't know. I don't know what this means. I don't know if we're wrong, or just not yet right. There's an honesty in that uncertainty, a kind of intellectual humility that science too often hides. Because at its core, science isn't a collection of facts. It's a process of perpetual unlearning and relearning, of being willing to say, what I believed yesterday doesn't work today. And now, that moment is here again. In the past, such moments have led to revolutions. Newton's universe gave way to Einstein's. Einstein's static cosmos gave way to Hubble's expanding one. Later, quantum mechanics rewrote the rules of the small, and inflation theory, once a fringe idea, became foundational. This is the rhythm of science. Certainty, contradiction, collapse, and then, if we're lucky, clarity. But this time feels different, because the cracks are appearing not in the margins, but in the core. It's one thing to refine a model. It's another to question whether the timeline of the universe, the sequence of its own becoming, is deeply misunderstood. If galaxies didn't form later, but early, if structures didn't didn't grow slowly, but suddenly, if time itself didn't unfold gently, but was bent or broken at the beginning, then our entire picture of cosmic history is not just blurred, it's upside down. For scientists, this is more than a theoretical challenge. It's a crisis of narrative, because we don't just build equations. We build stories that help us make sense of our place in the dark. And when the story fractures, the ground beneath us shifts. What Webb has triggered is not panic. It's deeper than that. It's the sense that the universe is more creative, more subtle, more complex than we dared imagine. And perhaps, more than anything else, this is what causes the quiet tension in research labs and journal rooms. Not fear of being wrong, but awe at how much we have yet to understand. Some scientists are now calling for a re-examination of first principles. Not a rejection of the Big Bang, but a recalibration. A humility that maybe, in the earliest epochs, something fundamental happened. Something that doesn't fit within our current toolkit. What comes next isn't clear. There may be new theories, new physics, or a convergence of ideas that reveal a layer of reality we've never seen before. But one thing is certain. This is not the end of cosmology. It's the beginning of a deeper search. Because when the cosmos refuses to fit your equations, it's not just your models that need revision. It's your sense of certainty. Maybe the universe we see isn't the universe we're in. A mirror doesn't show you the world. It shows you your position within it. And sometimes, if the reflection is bent just right, it lies. For over a century, we've stared into the cosmic mirror, collecting light from the farthest galaxies, measuring the whispers of ancient radiation, interpreting the stretch of space itself. We believed the image was complete. But what if we've been staring at a projection, not the source? What if the universe we've been trying to understand is only the surface of something deeper? It begins with Webb's mirror, not a metaphor this time, but literal gold-plated hexagons floating beyond the moon's gravity well. Its mission, to peer farther back than ever before, to catch the faint glimmers of creation's first sparks. And what it found wasn't just strange, it was destabilizing. Smooth galaxies that shouldn't be there. Gravitational structures too large, too soon. Cosmic architecture that defies the timeline carved by the Big Bang. So now, with standard models cracking under the cosmic pressure, some physicists are asking an audacious question. Have we misunderstood what a universe even is? Let's start with a radical idea. The Big Bang may not have been the beginning, but a bounce. In bouncing cosmologies, the universe didn't explode into being from nothing. Instead, it's part of a larger cycle: contraction, collapse, and then expansion again and again, forever. In this view, what we call the Big Bang is merely the turning point, a cosmic heartbeat, and every heartbeat before it leaves subtle imprints on the one that follows, echoes in the structure of space, distortions in the early universe's geometry, clues that might still be visible in deep sky maps. Then there's the conformal cyclic cosmology proposed by Roger Penrose. He suggests that the infinite future of one universe can become the birth of the next, a kind of temporal recycling, where the universe's dying embers stretch into eternity, until they become the seeds of a new cosmos. No singularity, no edge of time, just a looping eternity, where even death becomes a form of creation. Webb's data, with its hints of impossible maturity in young galaxies, doesn't prove these models, but it reopens the door. Because if structures had a head start, maybe they weren't starting from scratch at all. And then, there's something even stranger, something that once lived on the fringes of theory, but is now crawling toward the center. The white hole. If a black hole is a place where nothing escapes, a white hole is a place where nothing can enter. It expels matter, light, information, but never accepts them. It's the reverse of collapse. It's emergence. Some theorists propose that the Big Bang might have been a white hole, not from within our universe, but from beyond it. Imagine a black hole collapsing in another realm, a separate universe, a different layer of reality, and then rebounding into ours, spewing out everything we call the observable cosmos. In this model, we are living inside the event horizon of a white hole. The expansion of space isn't just growth, it's ejection. And the past isn't just behind us. It's on the other side of a wall we can never see through. This doesn't mean science has given up. It means we're beginning to admit the limitations of our vision, of our instruments, of our assumptions. Because maybe the light we see isn't the whole story. Maybe reality isn't made only of things that shine. And now comes the truly disturbing possibility. One that goes beyond physics into philosophy and consciousness. What if the reason we can't fully understand the universe is because we are embedded inside it? Like fish trying to measure the ocean's curvature, we are shaped by the very thing we're trying to map. Our perception, our cognition, our sense of time, they evolved inside this universe. We are products of its laws, not separate observers of them. So, can we ever really step outside? Physicist Lee Smolin once asked whether the laws of physics are timeless, or if they, too, evolve. If laws can change, if constants can drift, then even the very fabric of reality is fluid. And if perception plays a role not in a mystical sense, but in the deeply physical one, then observation itself becomes a creative act. Quantum mechanics has long hinted at this, that particles behave differently when observed, that the act of measurement collapses possibility possibility into reality. Could it be that our universe, the one we observe, is one of many potential versions, selected not by chance, but by interaction? If so, we return to that haunting line. Maybe the universe we see isn't the universe we're in. It's the version that our tools, our minds, our questions have made visible, but not the totality, not the whole. This doesn't make the universe less real. It makes it more profound, because now, we are not just spectators of the cosmos. We are participants in its unfolding, not its authors, but its translators, and perhaps, its children. So where does this leave us? At a crossroads. The standard model is no longer enough, but its collapse is not a failure, it's a beginning. We are on the edge of a deeper understanding, one that may not come from a single theory or a singular moment of clarity, but from a change in perspective. Maybe the next great cosmological revolution won't come from more data, but from learning how to see differently, because the cosmos doesn't just ask for explanations. It invites wonder. It demands humility. But if we've misunderstood how the universe began, what does that say about how it ends? The future isn't what we thought. We explore the new timelines and the possible fates that await everything. There's a silence deeper than sound. The silence of realizing you don't know what reality is, and never truly did. For scientists working at the edge of cosmology, this isn't poetry. It's a nightly truth. We often imagine science as a fortress of certainty ruled by logic, unmoved by emotion. But this is different. The James Webb Space Telescope hasn't just shown us new galaxies. It has unsettled the people who built it. In press conferences, they smile. In papers, they measure. But in private, many of them admit they are disturbed, haunted by what they've seen. Because beyond the dazzling images and historic breakthroughs, Webb has done something subtle, and far more dangerous. It has forced a confrontation, not just with the cosmos but with ourselves. In the earliest deep field images, we expected noise and smudges, hints of galaxies on the verge of being born. Instead, we found fully formed structures, elegant spirals, massive clusters appearing impossibly early. These weren't just anomalies. They were insults to the timeline. Some galaxies were too bright, too mature, too massive for the age of the universe in which they appeared. It was like opening a time capsule buried in ancient rock, and finding skyscrapers inside. No existing model could explain it cleanly. No patchwork of theory could fully make sense of it. And in that gap between what was predicted and what was observed, something else began to seep in. Doubt. You don't often hear scientists say the words, "I don't know what this means." But over the last year, those words have echoed across astronomy departments, conference halls, and midnight emails. One cosmologist anonymous in their interview confessed, "This is the first time in my career I've genuinely felt lost, like the map just stopped making sense." Another said, "It's not just confusion, it's existential, like we might be standing on the wrong foundation entirely." These are not the words of failure. They are the sounds of honesty in the face of the infinite. Because science isn't a monument. It's a trembling hand reaching out into the dark, hoping to touch something real. And sometimes, the dark reaches back. There's a quiet truth few outsiders realize. Science is emotional, not in the loud, dramatic way of fiction, but in the quiet hours. When an astronomer stares at data at 2 a.m. and realizes that nothing adds up. When a cosmologist tosses in bed, replaying equations that no longer feel anchored to anything. When a team looks at a breakthrough and instead of celebration, they feel a cold, creeping fear. What if the universe is stranger than we can understand? Not just complex, not just weird, but fundamentally beyond us. What do you do when the answers stop coming? When even the questions don't make sense anymore? This is the fear behind the wonder. The fear that we are standing at the edge of comprehension, not just temporarily, but eternally. That the laws of physics may not be laws at all, but shifting patterns in a deeper, unknowable sea. That reality may not be built to be known. That we are conscious creatures in a universe that is not obligated to make sense to us. And yet, we try. We build telescopes. We launch probes. We stare into black holes, and whisper theories about what lies beyond them. Because even when the night sky offers no comfort, something in us must look up. There's an old philosophical question, often asked quietly in the halls of physics. What if the truth is too big for the human mind? It's not defeatist. It's reverent. Because every scientific revolution from Copernicus to Einstein began with the same emotion. Discomfort. It is discomfort that forces us to let go of false certainties. It is awe that keeps us searching. The James Webb Space Telescope is not just a mirror into the early universe. It's a mirror turned back on us, on our need to know, our fear of not knowing, and our refusal to stop asking. And in that there is something profoundly human. We are the only species as far as we know that builds machines to question the fabric of existence. We burn fuel, climb gravity wells, freeze sensors in liquid helium, just to understand a photon that left its star 13 billion years ago. Why? Because something in us deeper than instinct, older than culture, is drawn to the edge of mystery. We stare into the dark, not to find comfort, not to find answers, but because something in us cannot look away. The night sky is not a void. It is a wound in the veil, a place where reality bleeds into into perception. And we keep looking, because behind every terrifying unknown, there might be beauty, not the kind we expect, but the kind that transforms us. So no, this story does not end with certainty. It ends where all great stories of science do, on the edge of awe. Because the universe is not a puzzle to be solved. It is a cathedral of questions, and we are still learning how to listen to its silence. There are moments in science when silence falls across entire rooms. Not because nothing is happening, but because something has happened that no one can explain. The James Webb Space Telescope was meant to be a confirmation, a final lens peering into the childhood of the cosmos. We expected to see the first sparks of formation, galaxies crawling out of the primordial dark, slowly assembling over hundreds of millions of years. Instead, Webb showed us something else entirely. Within just a few 100 million years of the supposed birth of the universe, it found galaxies large, bright, and structured. Not scattered clouds or forming clusters, but elegant spirals. Massive, mature systems that by all calculations shouldn't exist yet. As if skyscrapers had appeared in the ruins of ancient Earth long before concrete or steel was invented. Scientists stared at the images in disbelief. Source: 1749. GN Z11. Not names of comfort, names that would rewrite chapters of physics textbooks. These weren't rare exceptions. They were too many, too luminous, too consistent. The deeper Webb looked, the more the early universe resembled something finished rather than something beginning. We thought time was the sculptor of the cosmos. But what if time was cheated? As the data poured in, the anomalies multiplied. Gigantic galactic clusters that bent light and space in ways our models couldn't predict. Structures so vast they appeared to violate the limits set by cosmic inflation itself, that brief moment when the universe is said to have expanded faster than light. In the deep field images, we saw webs of matter stretching like nerves across the face of the early cosmos. Patterns that shouldn't have had time to form. Redshifts that didn't match expected distances. Light from objects that seemed far too evolved for their place in time. And then came the stranger things. Dark galaxies seemingly invisible, yet gravitationally active. Ultraluminous quasars in a universe still cooling from its fiery birth. Anomalies not just in what we saw, but in the frameworks we trusted. It was as if the universe was telling us, your questions are too small. Inside research centers and observatories, quiet panic began to grow. Some scientists tried to retrofit the data into older models, stretching parameters, tweaking formation rates, invoking hyper-efficient star birth. But the more they tried to force it, the more reality seemed to resist. Others proposed deeper revisions. Could dark matter behave differently in the early universe? Was cosmic expansion more complex than we thought? Or had we misunderstood gravity itself? And then, the most uncomfortable possibility emerged. What if the standard model, the Big Bang itself, needs to be revised? There are theories, whispered once at the fringes of academia, that now creep into serious conversation. Bouncing cosmologies, cyclic time, a universe born not from a singularity but from a white hole or reverse implosion. Concepts that sound fantastical, yet echo with strange consistency in the wake of Webb's revelations. And what if beyond the physical models lies an even deeper problem? What if the universe we're seeing isn't the universe we're truly in? Some thinkers are beginning to question the nature of observation itself. Are our instruments limited not by technology but by perspective? Is consciousness a filter? Does reality unfold differently depending on the framework of the observer? These are no longer just philosophical detours. They are becoming central to the very act of cosmology. For all our equations, for all our simulations, science is still a human act conducted by minds that wonder, fear, doubt. And now, scientists are beginning to say aloud the hardest words of all, I don't know what this means. Because what Webb is giving us is not just data. It is a mirror that reflects our desire for understanding, our belief in a rational cosmos, and our fear that maybe, just maybe, the universe is far stranger than we are equipped to grasp. And yet, we continue to stare, because embedded in every contradiction is the scent of something larger, a truth not yet within reach, but moving toward us. The telescope has done more than open a new window to space. It has opened a wound in our understanding, a beautiful one that bleeds questions more than it offers answers. But maybe this is the real function of science, not to provide certainty, but to deepen the mystery. To remind us that knowledge is not a wall we build around truth, but a path that curves endlessly toward the unknown. We stare into the dark not to find comfort, but because something in us cannot look away. And now, with Webb as our witness, we know the universe is not finished revealing itself. It never was.